All right, let's go ahead and let's solve these polynomial equations. We have added, subtracted, multiplied, even factored. Now it's time to solve. So the whole reason why I've been harping on about factoring completely is exactly for this reason. Why we've had to factor and factor since day one of this class is exactly for this one right here. So we have x cubed minus 7x squared minus 9x plus 63 equals 0. So when you're solving polynomial equations, method number one is to set equal to 0 and factor, just like you would with a quadratic, because the quadratic is a polynomial, but any polynomial you want to go ahead, set equal to 0 and factor. So this is a 4-term polynomial, meaning that we're going to go ahead and split it up into two groups. So we have x cubed minus 7x squared and negative 9x plus 63. So when we pull out the GCF of x squared from the first group, we're left with x minus 7. And now for this next one, I'm going to pull out a negative 9, and again, x minus 7. We know we factored it correctly because we have two x minus 7s, and we have x minus 9 times x minus 7 equals 0. We'll notice that the x squared minus 9 is a difference of squares, so it factors into x minus 3 times x plus 3 times x minus 7. And now we have 0 product property, stating that if our factors are equal to 0, then at least one of our factors has to equal 0. So we can now split this up. We have x minus 3, x plus 3, and x minus 7. So x minus 3 equals 0, x plus 3 equals 0, x minus 7 equals 0. Now when you solve each of these, we get x is equal to 3, x is equal to negative 3, and x is equal to 7. And those are all three of our answers. So one thing that I do want to point out about this is that it was a cubic. So it was a cubic, so we should have 3 answers. Let's put 3 answers, right? You should have the amount of answers at the degree of the function. Answers, I'm trying to spell and talk. There we go. So 3 answers, right? So if you have a quartic, you should have 4 answers. You might start to dive into the imaginary complex realm though. So just a heads up on that one. And these are exactly where this function crosses the x-axis. So when you're looking at graphing, this is something to think about, is that you can factor and solve, and this function would cross the x-axis at negative 3, 3, and 7. So let's try one more. Again with factoring, so example 2, we're going to try x cubed minus 3x squared minus 6x plus 18 equals 0. And again, you have these two groups. You have x cubed minus 3x squared and negative 6x squared plus 18. It's a 4-term polynomial. So we are going to, that got kind of funky there, sorry. Do it, factor this by grouping, so x squared times x minus 3, pull out a negative 6, and again, x minus 3 equals 0. This is very similar to the first one, but I just want to point out here that you can solve this because one of your factors is a quadratic, and we can solve quadratics. We can take the square root, we can isolate that square and take the square root. So this one, we can now break down, even though x minus 6 can't be factored anymore, we can break this down to x squared minus 6 equals 0, and x minus 3 equals 0. So solving this by adding 6 to both sides and taking the square root, leaving us with x is equal to plus or minus square root of 6. And you, of course, would add 3 to both sides for x is equal to 3. And again, we have 3 answers because we have x is equal to positive square root of 6, x is equal to negative square root of 6, and x is equal to 3. All right, so of course we can factor, and you guys are factoring geniuses, especially after today. But what do you do if you cannot factor? So if you cannot factor, you're going to use rational roots theorem. Roots theorem. There we go. All right, so rational root theorem goes ahead and basically it says if you have a polynomial, so if f of x is equal to, we're going to call this a sub n, x to the power of n, plus so on and so on, whatever's in the middle, plus a sub 0. Basically that a sub n is your leading coefficient, a sub 0 is that last term there in your constant. And it has integer, there we go, coefficients. So this only works with integer coefficients. Then every rational, hint rational there, every rational solution of f of x equals 0, that's basically just the math way of saying it, any rational solution has the form p over q, where p is factors of the constant a sub 0 over, sneak in there, factors of the leading coefficient, a sub n. Okay, so that was all fancy terms. This is what we're basically saying is that if you have integer solutions for your polynomial, then it's going to go ahead and going to have factors of your leading coefficient on the bottom over factors of your constant there on the top, p. So going ahead and looking at an example, let's choose this blue. I like this blue. So we're on example 3 here, is that we would have something like x cubed minus 8x squared plus 11x plus 20 equals 0. Okay, so first of all, we have these are all possible solutions. They don't have to be solutions, they're possible. And our last term, or our constant here is 20. Of course, our leading coefficient there is 1. So when we think about factors of 20, right, we could think about 1, 20, we could think about 2, 10, 4, 5, right? And then, of course, factors of 1 are just 1. So it's really nice when your leading coefficient is 1 because you don't have to worry about a whole bunch of different kind of fractions there. Now, here's the tricky part, is that it has to be, you can either have positive or negatives on these because you could think about, okay, well, you can multiply negative 20 by negative 1 and still get a factor of 20 on there. So don't forget those negatives and positives on there. So these, again, are all possible solutions. Now, are they all solutions? No, right? But they are all possible. So to go ahead and check them out, we're going to use our synthetic division. And we know from today that if we have a remainder of 0, then yes, it's a factor. So let's start with 1, right? So starting with these factors right here, we have the possible solutions of 1 and negative 1. So starting with 1, put 1 in that divisor box. We're going to have our coefficients 1, negative 8, 11, and 20. Let's check out that synthetic division by skipping a line, bringing down that first term. 1 times 1 is 1, negative 7, add them to 4. 4 times 1 is 4. Oh, that's 24. Okay, so 1 does not work. I'll even get out my little red X here, right? 1 does not work. It is not a factor. Moving on to the next one. -1. This might seem crazy, but I promise I won't give super hard ones. Let's check this one out. So 1, -8, 11, and 20. Okay, so again, bring down that 1. Now we have -1, -9, 9, 20, oh, -20, 0. Yep, let's get out that green. Let's do a nice green here. Yep, absolutely. -1 does work. So we know that -1 is a factor. Okay, so knowing that -1 is a factor, we can now factor this. So we can factor it into x squared minus 9x plus 20, but don't forget that you factored out that -1, so x plus 1. Please, I'm going to even highlight this right here. Please don't forget, oops, that's not what I wanted to do. I'm going to do it with this one. Don't forget that factor there, right? I'll even add a note, don't forget factor. I see that all the time. Okay, so now that we've factored this is now a quadratic and a linear, we can solve it. All right, so this is actually equal to 0 here. I'm just fitting in a lot in my little notes, I apologize. Usually they're a little bit cleaner. Let's go ahead and let's break, we can factor this, this 20 and, sorry, this quadratic. So we can factor this a little bit more, giving us x minus 4 and x minus 5, and again, x plus 1 equals 0. All right, now they're all linears. We can set them equal to 0, so x minus 4 equals 0, x minus 5 equals 0, and x plus 1 equals 0. Solve them. X is equal to 4, x is equal to 5, and x is equal to -1. All three answers there ready to go for you. Okay, so basically just to sum this up, I'm going to look at this just a little bit, is that you want to figure out your possible solutions and then use synthetic division to figure out if they are factors and then solve from there. Questions? I will see you tomorrow. Hope you're having a great evening.